Any questions on that? Okay. All right, let's keep going then. So this was one, so polynomial long division, you know, it's very useful. It's a little bit, you know, it can get kind of tedious at times. So there is a shortcut for doing it. Namely, what we have is this, synthetic division, and that occurs when d of x is of this form. And you can always use long division if you want, you know, but synthetic division is useful if you're able to use it. Namely, if your d of x is of the form x minus a, you know, where a is some number, okay? Then you can use synthetic division. And again, this is illustrated by example. Okay, so let's do that. So the coefficients of capital F, right? Again, capital F is the dividend. You're dividing d of x into it. You want capital F in standard form. That's what I mean by descending powers of x. And if you're missing a term, you add 0 as the coefficient for each missing power. Okay, you're definitely going to want to do that. Basically, what's going to happen is this, as illustrated by this example, okay? Here we have this polynomial. We're dividing it by x minus 3. So this is our d of x, our divisor. This is our dividend. This is our dividend. This is our dividend. So we have 2x to the 4. Notice we're missing an x cubed term, right? So we put in 0x cubed. Minus 3x squared. It's already there. 5x, that's there. Minus 63, that's there as well. As you can see. Okay. Okay. So now from here, right? What do we have now? Well, we're going to make a grid where each coefficient here is going to be a column. Each coefficient there is going to be a column. Okay. Right, so we have 2x to the 4, 0x cubed, that goes here, minus 3x squared goes here, 5x is here, and minus 63, that goes here also. Sorry, I had to blow my nose. Okay, so that's what we have here. Now, so these are the coefficients, okay? Again, 2x to the 4, 0x cubed, minus 3x squared, 5x, minus 63, okay? So that's what we have here. Good. Now, there's going to be another column on the left. That's the 3 for x minus 3. That's the 3 for the x minus 3. Okay. Okay. So how's okay? Now we're set up. Now we're ready to actually do the work calculations. As I have down here, this 2 you're going to bring down. Then you do 3 times 2, which is 6. That 6 is going to go here. You know, the product. Then we have 0 up here, right? So we have 0 plus 6, right? And that's going to go down here, as you can see. Okay, so again, let me say it again. What did I do? The 2 comes down. We have 3 times 2. That's 6, and that product goes here. Then we're going to add 0 plus 6, and that sum is here, 6. And the whole process repeats. We have 3 times 6, which is 18, right? That 18 is going to go in this blank entry. Then you have negative 3 plus 18. That's going to be 15, which is down here. Okay. Then we have 3 times 15. That's 45. 45 goes here, as you can see in this grid. So we have 45. We add 5 to 45. That gives us 50 down here. We get this down here. And finally, we do, well, not finally, we get 3 times 50, which is 150. That's going to go in here. And then we add to get 87. Okay, we add to get 87. So that's synthetic division. Okay, now how do we get our answer? Well, it's the bottom row here that we really care about. The last number here, that's our remainder, which is always going to be a number. You know, by the division algorithm, the remainder is either 0 or 1 degree, or degree less than the degree of the divisor. The divisor is degree 1. So the remainder here will be 0 or have degree 0. Either way, it's a constant. You know, the only polynomials, of degree 0 are non-zero constants. So we have our remainder. These are the coefficients of the quotient. That's what these are. These are the coefficients of the quotient. Okay, and it's always 1 degree less than the dividend. So I think here, what was it, degree 3, I think? What was it? Let me see. Here, 4 actually. So the quotient's going to have degree 3. We have 2x cubed plus 6x squared plus 15x plus 50. See, that's what our quotient is. This is our remainder. And using the division algorithm, you can, what you can do is you can write it like this if you want. I mean, you'll see this is actually useful to do. You can write it like this. Okay. Good. Hold on. Can I re-explain all the steps? I'm going to do another example, so I'll do those. I'll go through that one, okay? That should help, I think. Someone asked if I could re-explain it, so yeah, I'm going to do another example, so let me do that. Okay. All right. Are there any questions about this one though? Any other questions? I mean, that's a good question though. So the next example should clarify a bit. I mean, the whole point is this number, right? You get the top row, and what you do is this number comes down here to 2. You're going to wait, let me put the laser thing. You're going to multiply, the product goes here, then you add to get this, then repeat, multiply, put here, add to get this. Multiply, put here, add to get this answer, and so on. And then multiply, put it here, then add. That goes here, and you stop here because there's nothing after this. So, all right. For this one, let's do it as well. So here, notice we have, okay, this is our dividend, capital F of x. We're dividing it by this. So what we have then is this. We're going to have this 3 as for this column, okay? That's for this column. The 3, it's x minus 3. 3 goes here. Okay. Now here, notice we want to put the coefficients, okay? 1 coefficient for each column. So the 2 goes here. -7 goes in here. That's another column. We're missing an x term, right? So we're going to use 0 as a placeholder. Kind of like what we did with addition, subtraction, and just before polynomial long division. If we're missing a term, you're going to have 0 times, you're going to use 0 as a placeholder for the coefficient. So normally you would have 0 times x here. That's where this 0 comes from. Then the constant term 5 comes here. Okay, beautiful. What do we do next? The 2 comes down, okay? And what you're going to do next is this. You're going to multiply 3 times 2, and that is going to go here, the product, which is 6 in this case. So you bring this down, you're going to multiply, and that product's going to go here. Next, you're going to add, and that goes here. Right? You're going to add these two terms, and that goes down here, the sum, which is -1. And now you repeat the process. 3 times -1, that's -3, right? That's going to go here, as illustrated here. Then you have 0 plus -3. Well, that's just -3, so that goes here. So it's a pattern, basically. As you can see, it's a pattern. We have -3. Now we repeat the process. We have 3 times -3, right? Which is -9. -9 is going to go here, right? So again, 3 times -3, that's going to go here, which is -9. That goes here. And then we add, and whatever goes here is, and what goes here, well, the sum, which is -4. And we stop because there's nothing after it. Okay, so again, what we have is the remainder is this last term. So here the remainder is -4. The quotient is 1 degree less than the degree of the dividend, which is degree 3. And these are the coefficients of the quotient. 2x squared minus x minus 3. And that's what we have. This is our quotient. Here's our remainder. Okay. So altogether, we have this, our dividend, is x minus 3, that's our divisor, times our quotient, plus the remainder, which in this case is -4, so it's -4. Yeah, I'll just do that. Okay. All right. Good. All right. Did that help, or let's see? I hope that helped everyone. Like, some people are confused about the steps.